Welcome to the Empowering Tomorrow's Automotive Software Podcast, brought to you by ETAS, a single source of cutting-edge software and hardware solutions that make automotive embedded systems safe, smart, secure, and sustainable. Each episode, we'll be joined by ETAS and industry experts to discuss how electrification, automation, and connectivity are impacting the automotive industry. Now, sit back and enjoy the discussion.
Welcome to today's edition of Empowering Tomorrow's Automotive Software. I'm your host. My name is Tim Foster. I'm a senior solution consultant here at ETAS Inc. I have over 30 years of experience in the automotive embedded control space. There's a lot of noise being made about innovation in the automotive control space, but nobody's really talking about how to get there. Everything's getting more complex, from vehicle features to software driving those features, all the way down to the computers that run that software, the microcontrollers. As the brain of the vehicle software, these mini computers don't just happen, they need to be programmed to carry out important vehicle functions. Hence the industry challenge, programming these microcontrollers at an increasingly faster pace without sacrificing quality, reliability, cost, market pressure, regulations. And that's the focus of today's episode. I'd like to introduce our guest, Nigel Tracey. Nigel is the president of RTA Solutions at ETAS. He is a general manager for the ETAS Embedded Software Competency Center in York, UK. He's responsible for coordinating the AUTOSAR participation and product strategy across the ETAS group, and he's published more than 30 papers on embedded real-time and safety critical systems.
Hey Tim, it's nice to be with you today.
All right, great, Nigel. Good to talk to you. Nigel, what are the current process and tool chain challenges in the developing the microcontroller-based automotive systems?
So you gave a very good intro there, and the challenges that we face more and more at the minute is with the increasing level of functionality that's being introduced into the vehicle, driven by software, that is requiring coordination across many of the different embedded control units in the car. So if you go back even just a decade, basically there was one function in one ECU delivering one feature, typically for the end driver to a large extent. What we've really seen change a lot, which is driving a huge amount of the complexity in developing those systems today, is that features require several ECUs to coordinate together. I mean, if you look at a typical modern vehicle on the road today, even with relatively basic driver assistance systems, there might be somewhere between 6 and 10 ECUs all trying to make a decision, should the car be going faster or slower right now. And there's a lot of coordination going on the network in the car, so they all come to the same conclusion in the same circumstances. And that's a lot of integration testing effort for the OEMs at the minute to get that working and to make sure all the corner cases are considered. So that's a huge new challenge, is bringing in this kind of vehicle level decision making in today's distributed system, where basically the software is distributed into a number of discrete separated ECUs. And that's driving the complexity of creating the software for these microcontroller environments and driving the complexity of the tool chain. So if I just look in using AUTOSAR Classic today, the complexity, the number of software components, the number of signals, the complexity of the AUTOSAR XML configuration is growing tremendously to handle all of this. And what we see is most of the OEMs moving towards a approach to centralize or add a centralized layer into their EE architectures to bring some of that decision making into a central point where it's a bit easier to make. So yeah, primarily today, I would say it's this problem that it's no longer one feature in one box delivering one function for the end driver, but this complex coordination of vehicle decision making between maybe 6 to 10 to 12 boxes in the car, and then that integration testing and validation effort. And of course, because the car's a highly safety critical system, you get it wrong, the car can become dangerous. So it's the scale of the challenge is an important one, because you can't afford to risk safety.
Right. So you've talked a little bit about, let's say, the complexity of the different types of functions, let's say, and there's a lot of new functions coming about: autonomous driving, electric vehicles, vehicle security. But then on top of that, you also have to balance, let's say, the customer expectations too, in terms of how they view the vehicle and how they interact with the vehicle, right? How do those sort of aspects play into being able to manage that software complexity as well.
Yeah, I mean, what you really see more recently is there's two kind of core areas where the vehicle owner is willing to spend money on features and functions. But the expectation of what just comes with the car has grown enormously. The kind of comfort functions and features that you expect as a baseline in a car has grown tremendously over the last decade alone. But the two areas where it seems we as consumers are willing to spend our money is in driver assistance of increasing levels of autonomy and in integration with our digital lives. So the vehicle entertainment, digital cockpit kind of areas. And they're the two areas that it seems we as consumers are willing to spend the money. And certainly when you look at things like autonomous driving, that's where a lot of the challenges that I said are coming from, because typically they're not so easy to deliver in a single ECU. It requires several ECUs to coordinate, or at least to coordinate with other systems in the car. So, you've got your adaptive cruise control, but also your pedestrian detection protection system. You've got your emergency braking system and your ESP system. And these all have to fit and work together. So the things we're interested in as consumers are driving these kind of cross-vehicle challenges that require multiple systems to work together much more intensively than maybe it was in the past. And that's leading to this decision making becoming very important as to what should the car do right now. And that's a very complicated problem if it's distributed. And hence, as I mentioned previously, that's what's driving a lot of the industry towards these more centralized architectures, which I think there's a bit of a misnomer in the industry. It's not so much centralization to remove today's embedded control systems. I mean, you've still got to control the brakes, you've still got to control the engine, you've still got to interact with the radar for the adaptive cruise control. But you can centralize that decision making into one place and then communicate to all of those systems, effectively making them feel from the development process a little bit more like smart sensor actuators that just happen to be driven by software. But at least you can, with this approach, you can take a lot of the decision making complexity away from them and leave them just focused on their controls task.
Right. So with the complexity of all these different systems, just like you were talking about, that you have this sort of centralized decision making, how does an organization manage all these different pieces of software such that to the consumer it looks like it's very well organized? Because it sounds extremely complex. And how do each one of these groups, if you will, that are developing individual pieces of software, how does the organization, the OEM, the manufacturer, ensure that all these pieces of software talk to each other correctly? That sounds like a
Yeah.
huge challenge.
Absolutely, and it's a growing challenge. So I think, if you go back 25 years ago, when vehicle buses were just being introduced, when CAN was first introduced in the late 90s or mid 90s, what you saw then is basically a supply model which was the car manufacturers would specify one feature and function to be in one ECU, very often connected with their business model for the car. That would be one option for the driver to buy or not buy, and it would be delivered by a tier one. And then the job of the car manufacturer was largely about managing how those things just exchanged data on the network. But the coordination level was relatively simple. I mean, they had to exchange data to fulfill their function. When I press the button to open the window on my driver's door, I want the passenger side window to open, which means sending a message, receiving it. But what you see now is the challenge, especially for the OEMs, is growing a lot because that centralized architecture, or today, even before the centralized architecture, they're the ones that have to do all this testing and validation to make sure the distributed decision making is made correctly in all cases. I remember talking to an OEM 6-7 months ago. They'd figured out their state space for the 6 ECUs that are involved in deciding whether the car should be going faster or slower right now, has round about 180,000 states. And they have to be confident that that all 6 ECUs come to the same conclusion about what the vehicle should do next. All 6 of them have to come to the same answer in every one of those 180,000 states. And that's a testing nightmare when you've got to be confident it does that to safety critical levels where someone's life could depend on it. And what you're seeing now more and more is the big challenge that the OEMs are having to rise to is if you move to a more centralized architecture, then also the OEMs have to take more responsibility for the software for that centralized decision-making layer. And that's something that is having to grow up very rapidly now because, as I said, 20 years ago, that problem was distributed into the tier one supply base where they would deliver software but in a silver box. So to the OEM, it was a piece of hardware with a system attached that just happened to have software in it. But now that decision-making largely has to be the responsibility of the OEM because no one else can manage that centralized decision-making point because it's a vehicle level functionality and it becomes a systems engineering problem for the OEMs, which if you look in other industries like the railway industry or the aerospace industry, that's what Boeing and Airbus are in the aerospace industry. They're systems engineers, but that's a very new task for the OEMs to grapple with, especially given already today there's no more complex software system on the planet than a car. I mean, there's hundreds of millions of lines of code. It's safety critical. It's resource constrained. I mean, I think there's no more challenging environment. And now suddenly the car manufacturers get this additional task to become very advanced systems engineers and systems integrators, which is required for the things we as consumers are willing to pay money for. So if they want to keep getting more and more of our money and selling us the options, then this challenge is only growing.
Right, and I would say added on top of that is this, let's say, situation where the technology itself is evolving very rapidly, right? And let's say the regulations are evolving rapidly, as well as the expectations of customers are evolving rapidly. And what I see, and I guess I'd like you to confirm that, is that the additional challenge then is the OEMs, the tier ones, they have to build essentially additional capacity, if you will, into the systems from the beginning to allow them to be expanded and reprogrammed later, to adapt to maybe to new functionality or new regulations and these kind of things. I mean, I just was listening to the news this morning and they were talking about the automated emergency braking systems and how the early versions were not so effective, and now the latest versions are, quite effective, maybe even 100% effective, and just in the course of 1 or 2 years. So how do the OEMs and tier ones manage that sort of acceleration of these kind of things as well?
Yeah, absolutely. So I think your observation is correct here, and this is another layer of challenge that the OEMs have at their feet. So I think it's a really tough time. They have so many things coming together all at the same time in terms of challenges, and this is definitely one of them because we've all started in the smartphone era, getting used to the fact that on the day you buy your nice shiny new smartphone, that's as bad as it's ever going to be, because from that point on, it's constantly updated with new apps, new versions of the operating system and new capabilities, and it just gets better over time. But for all of automotive history, basically a car is the best it's ever going to be on day one, and all it does is get older from that point. But now we have the expectation that, well, why can't it be updated? Why can't it improve? Why can't it get the new functionality, like you said? And now you're facing two worlds colliding. You've got that expectation from us as consumers, colliding very much with the automotive industry is a run on tight margins. It's hard to build in significant overhead and spare capacity in these systems because you're producing millions of them. So leaving unused memory, unused CPU cycles isn't such an easy thing to do. And then in addition, if you're going to be updating them, you also have to take care that they remain safety critical. I mean, the car, although there's a lot of talk about it, I am really not a fan of the discussion about a car being a smartphone on wheels. It's not. It's fundamentally different. First, because it's a hard real-time control problem. So everything's got to happen on time. And very often for a lot of features and functions in a car, if the right answer shows up a little bit late after the deadline, it's just as dangerous as the wrong answer showing up. Firing an airbag too late can kill someone. So real time is important. A lot of the functionality is safety critical. So if you're updating it, you've also got to be confident that it remains safe as it was when you first released it. And that's no easy challenge. And then, of course, if it can be updated, you've also got to be confident that you've got all your security mechanisms right, because If you need to reason about safety, then you have to be sure only safe software can be deployed, which means you've got to lean very heavily on underlying security to make sure only authentic, correct software updates can get deployed. And that's why I say I think it's a very complex systems engineering problem, and the OEMs are having to become very advanced systems engineers. And in some cases, it's already more challenging than you might see in other industries because a lot of the topics, like I just mentioned, with updates and security, they don't exist in the same way in the railway infrastructure and the aerospace because you've got physical security of planes. You don't roll it out to 90 million users and let any of them update anytime they like. In automotive, that's how it has to be because everyone updates their vehicle at home. So there are some unique challenges that make that systems engineering problem worse. But yeah, the OEMs who can't master that are going to have a problem because we as consumers now expect our cars increasingly to get new features after we buy it and to improve just like we got used to with our smartphones.
So now that we've talked about all the challenges, let's talk about maybe how ETAS can help these industries solve or at least mitigate some of these challenges. Do you have some ideas there?
So I think obviously I mentioned one of the underlying things that's very important because it's the root of being able to deliver a lot of this is a strong trust anchor that you solve the security problem. So if you don't get security right, basically you're on a very difficult path to solve any of the other challenges that are delivering this value. So here, having approaches with strong cryptography, making sure each ECU has unique keys, your authenticating messages, these are all important things. And this is something that's supported in the basic software and the security stack that ETAS can support with. Of course, there's other solutions out there too. So that's one very important element, I think, to building the system is to have that strong root and anchor of trust. The other thing that I think we will increasingly see, and you see this if you start to look at some of the kind of new automotive players that have entered the market. So some of the new entrants from the US or China who are new into the automotive market building electric vehicles. What you see increasingly with them is a shift in focus that they very much focus on these centralization ECUs and take care of their systems engineering jobs. And that requires new approaches, service-oriented architectures, more dynamic approaches to the software than the classical world where everything is designed and statically configured before you build the software. But what they also do increasingly is see most of the other ECUs in the car as smart sensor actuators. And they put much less effort into those, much less effort into having unique requirements for those, and just more and more see them as things they can buy off the shelf. And that might be a necessary thing just to have enough engineering bandwidth simply available to focus on things. So, seeing the window lifter and the seat positioner just as a smart sensor actuator and not having requirements documents of hundreds of pages. That's one approach to shift and have enough effort, because if we need to put the same amount of effort into those systems that we did the last 25 years and enough effort for the new centralized layers, we're going to run out of engineers in the automotive industry. I mean, we already know we've been struggling to hire them fast enough and to bring in enough software engineering capability. So it probably also means focus and maybe leaving some of the things again a little bit more to the tier ones and not to make them unique developments, but things that can become closer and closer to off-the-shelf products could be one way that helps. So, having a simple, it's an AUTOSAR stack, but you don't have to specify everything as an OEM. You can just take something off the shelf and then consider it a smart sensor actuator that has a CAN API. You don't necessarily have to specify everything to every detail so that you've got enough engineering capability. So that's one approach that could help, and how we can help with our AUTOSAR solutions, our security stack, to have enough effort to focus on the new centralized high performance computers in the system, because the effort's got to come from somewhere, and I'm sure we don't just get to hire another 60% of engineering staff in our companies.
So in other words, the OEMs can really rely on partners like ETAS who have many, many, many years of experience in the embedded space for providing these types of solutions and have millions of miles on the road, right, as ETAS does for for many of their solutions, correct?
Yeah, absolutely. I mean, we're homing in with our AutoSAR Classic solution where we're nearing 4 billion ECUs on the road powered by that. But it's, it's something in the public mind. No one ever heard of RTA car. Yet there's nearly 4 billion copies of it out there, which is, more than iOS. But it's hidden under the hood. It's just sitting there reliably doing its job day in, day out there. So yeah, absolutely. These proven solutions that you can just take from the shelf and use are definitely one way that you can shift then your limited engineering capacity and your focus then to the things that are differentiating for your customers. I often say this, I don't believe it's ever happened in the history of humankind anyone ever went into a car showroom and says, I want this car because it's got an awesome can stack inside. These things are just the foundation required to deliver the features we want, but it's the hidden underlying non-differentiating layer.
Are there is there anything else that you'd like to share with our listeners? Maybe some new things that are coming from ETAS that might also address some of these concerns we discussed?
Yeah, so I spoke a lot about the complexity of this integration and how that's driven by the especially autonomous driving features, because that's bringing and coordinating a lot. I mentioned the other area where we as consumers are willing to spend money is the kind of integrating the car into our digital life. So convenience features, downloading new capabilities and apps. I mean, that's the buzzword that we hear everywhere in the automotive industry at the minute of the software-defined vehicle. But this is definitely an area that is being worked on intensively by the whole industry at the minute is how will we deliver new capability to the vehicle? And especially if it's not updating the control algorithms or updating something that's safety critical, how can we have an environment in which you can develop new apps that are integrated with the vehicle, accessing vehicle data, but delivering new capabilities and features for the driver in a way that is much more like developing an app for the smartphone, so that you don't have the kind of legacy development environments that are very good for hard real time, very good for safety, but not really very good for building something in a week and getting it shipped to consumers. That's definitely a big focus, something we're intensively working on here at ETAS with our edge stack middleware to provide a modern middleware that's capable for these kind of features. And again, it's not something that will replace what we have already today. It's something that's layered on top to add this new capability to build in new features, deliver them in the matter of hours or days, rather than, you don't really want your ESP braking system to be delivered in hours or days. You want to make sure it's going to work in every circumstance. But this combination of things is definitely something. And on that new development environment, that's something of intense work here of us all at ETAS to bring that to life and give the ability that you can write a new app, be testing it in a vehicle in a few hours, and then maybe deploying it to customers within a few days, rather than the typical life cycle, which is months.
Okay. Well, thanks, Nigel. I think in summary, what I heard is, there's huge challenges in the industry. ETAS provides some level of stability. Let's say even this very changing environment, right? We've got the baseline stuff that we've been supplying for years, which can provide the OEMs and the tier ones that, let's say, confidence layer, if you will, for the more traditional development environments, and still provide some of this additional capability, which allows these features to be developed at the pace that the industry is looking for, right?
Yeah.
So that's great. Are there any other closing thoughts that you might have today, Nigel?
No, I think you wrapped up there, Tim, with a very nice summary of the challenge we have ahead. I mean, maybe I can wrap up from my side just with a personal reflection. So, when I first started my career, I worked in the safety critical industries in aerospace, in nuclear for a while, and then I took an active decision. It would be interesting to join an industry that was maybe a little less conservative and faster moving with technology. And back in the late 1990s was when I entered the automotive industry. And back then, I immediately realized I'd made a horrible mistake because it was even more conservative than the aerospace industry, even slower moving, even further behind in technology. But now I have to say it's a very exciting time. I've never seen it move so fast, never seen the technology moving. I mean, we keep hearing this, that the automotive industry is going through a transformation. So, yeah, finally, 25 years later, I can say I made the right decision there, because it's definitely a fun and challenging place to be right now, handling all of these new topics.
And I can second that opinion. I didn't spend any time in the other industries, but I've always been able to find exciting areas to be involved in, and this is definitely an exciting time. It's a great time to be an engineer, I think.
Yep.
All right. Well, thank you for joining our podcast today, and thanks for listening.
Thank you for joining this episode of the Empowering Tomorrow's Automotive Software podcast. Please leave a comment or review with your feedback or what you'd like to hear in future episodes. To learn more about automotive embedded systems and ETAS's capabilities, visit our website at ETAS. That's ETAS.com.